Imagine a telescope so powerful that it can look billions of years into the past. A telescope capable of observing galaxies that formed shortly after the birth of the universe. One that can peer into the regions where new stars are born, and even analyze the atmospheres of planets orbiting distant stars. When the James Webb Space Telescope began its mission, scientists expected groundbreaking discoveries. What they didn't expect was that within just a few years, it would begin challenging some of our biggest ideas about how the universe works. Almost immediately, Webb revealed galaxies that appeared to have formed far earlier than anyone thought possible. It uncovered hidden stellar nurseries that had remained invisible for decades. It allowed scientists to study the atmospheres of distant worlds and provided new clues in the search for life beyond Earth. What's even more remarkable is that many of these discoveries raised more questions than they answered. Because sometimes the greatest breakthroughs in science don't come from solving a mystery. Sometimes they come from discovering something no one ever expected to see. Today we'll explore 5 discoveries made by the James Webb Space Telescope that surprised astronomers the most and revealed that the universe may be even more extraordinary than we ever imagined. But before we dive into those discoveries, let's take a moment to meet the true star of this story. The James Webb Space Telescope is the largest and most powerful space observatory ever built. Its iconic golden mirror is made up of 18 hexagonal segments and spans more than 6 meters across. That's more than twice the diameter of Hubble's mirror. But the true power of this observatory isn't just its size. Webb was designed to observe the universe primarily in infrared light. That allows it to see through vast clouds of cosmic dust and detect light that has been traveling across space for billions of years. The farther Webb looks, the farther back in time it sees. In many ways, it's the closest thing we have to a time machine. And it's this extraordinary ability that made the discoveries you're about to see possible. The first came when astronomers turned Webb's giant mirror toward the most distant reaches of the universe. For decades, scientists believed they had a solid understanding of what the young universe looked like. According to our best models, small galaxies formed first. Over time, they merged, grew larger, and gradually built the enormous cosmic structures we see today. It made perfect sense. Small galaxies first, large galaxies later. So when Webb began exploring the most distant regions of the cosmos, astronomers expected to find exactly those kinds of young, relatively small galaxies. Instead, they found something no one had anticipated. Webb revealed galaxies that appeared far larger, brighter, and more evolved than they should have been at such an early stage in the universe's history. Some of them already existed just a few 100 million years after the Big Bang. On a cosmic timescale, that's an incredibly short period of time. For comparison, the universe itself is about 13.8 billion years old. It's a bit like planting a tree seed, coming back a few days later, and finding a fully grown forest instead of a tiny sapling. Scientists immediately began asking questions. How was this possible? Did the first galaxies grow much faster than we had ever imagined? Or were entirely different processes shaping the early universe in ways we still don't understand? For a time, some researchers even suggested that parts of our models describing galaxy formation might need significant revisions. As more observations came in, part of the mystery began to unravel. Some of these objects turned out to be different from what the earliest data had suggested. Even so, one thing became clear. The early universe was far more active and far more complex than we had ever imagined. And that was only the beginning, because if those unexpected galaxies challenged our understanding of the early cosmos, the next discoveries allowed us to look into places we had never truly seen before, places where new stars are born. When we look up at the night sky, the stars seem calm and unchanging, but every single one of them had a beginning. For decades, astronomers tried to witness that process. The problem was that stellar nurseries are hidden deep inside enormous clouds of gas and dust. It's a bit like trying to see through a thick fog. You can make out its shape, but you can't see what's happening inside. The Hubble Space Telescope captured breathtaking images of these regions, but in many cases it could only reveal their outer layers. Webb, however, observes the universe in infrared light. That allows it to see through much of the cosmic dust and reveal what had remained hidden until now. One of the most spectacular examples is a region known as the cosmic cliffs. At first glance, they look like enormous mountains rising through space. In reality, they are towering walls of gas and dust located thousands of light-years from Earth. And they are one of the places where new stars are born. Images captured by Webb revealed hundreds of young stars hidden within those clouds. Some of them are so young that they are only just beginning to illuminate the surrounding gas. For the first time, humanity was able to watch this process unfold in extraordinary detail. And this is where Webb truly shows what it was built for. It's not just a telescope that captures breathtaking images, it's a scientific instrument that allows us to witness the very processes responsible for the birth of stars, planets, and entire planetary systems. As we look at these distant clouds, we're also looking deep into the past. Perhaps this is what the region where our own sun was born looked like billions of years ago. Along with it came Earth, and eventually everything we know today. But the birth of stars is only part of the story, because many of them are surrounded by planets. Some are scorching worlds, others are frozen realms locked in eternal ice, and some may have conditions that could support life. For most of human history, all we could do was imagine what these distant worlds might be like. Today, we can do something far more extraordinary. We can study their atmospheres. Can we really determine the composition of the atmosphere of a planet trillions of kilometers away? Just a few decades ago, that would have sounded impossible. Today, Webb does exactly that. And it all comes down to an incredibly clever observing technique. When a planet passes in front of its host star, a tiny fraction of the star's light passes through the planet's atmosphere before reaching the telescope. That's where the real science begins. Different gases absorb different wavelengths of light. By analyzing those tiny changes, astronomers can determine which molecules are present in the atmosphere of a distant world. It's a bit like figuring out every ingredient in a meal just by smelling it. It sounds almost unbelievable. Yet that's exactly how scientists study exoplanets today. Take a moment to think about that. Humanity has never sent a spacecraft there. We've never collected a single sample. No one has ever set foot on those worlds. And yet we can determine what their atmospheres are made of. Just a few decades ago, something like that seemed impossible. Today, it's becoming part of everyday astronomy. Within just its first few years of operation, Webb detected water vapor, methane, carbon dioxide, and other chemical compounds in the atmospheres of distant planets. For astronomers, that's a treasure trove of information. Every molecule tells us a little more about the conditions on those worlds. Are there clouds? Could there be oceans? How hot is the atmosphere? And could any of these planets offer conditions where life might have a chance to exist? Particular attention is focused on planets located within what's known as the habitable zone. That's the region around a star where temperatures may allow liquid water to exist. Of course, that doesn't mean life is actually there. But if we're ever going to find an inhabited world, this is where the search has to begin. Webb hasn't discovered alien life, nor has it found definitive evidence that life exists beyond Earth. But it has accomplished something just as remarkable. It has shown that we can study distant worlds with a level of precision that seemed impossible only a few years ago. For the first time in human history, we're not just discovering new planets, we're beginning to understand what their atmospheres are actually made of. And this is only the beginning. While astronomers were studying distant worlds, Webb was uncovering something even more mysterious. Objects that, according to many theories, shouldn't have had enough time to grow so massive. We're talking about supermassive black holes. Black holes are among the most mysterious objects in the universe. Their gravity is so powerful that once anything crosses a certain boundary, not even light can escape. And yet astronomers can detect them by observing the effects they have on the matter around them. For decades, scientists have known that the centers of many galaxies are home to true giants, supermassive black holes. Some contain millions, or even billions, of times the mass of our Sun. For years, astronomers have tried to understand how objects this enormous could have formed. Webb provided new clues, but at the same time, it made the mystery even deeper. While observing some of the most distant galaxies ever discovered, Webb found supermassive black holes that already existed when the universe was still incredibly young. And that's where the puzzle begins. According to many current models, they simply shouldn't have had enough time to grow that large. And yet, they were already there. That discovery sparked intense debate among astronomers around the world. It's a bit like meeting a 5-year-old child who's suddenly as tall as a fully grown adult. Something doesn't add up. Perhaps the very first black holes formed in ways we still don't understand. Or perhaps they grew much faster than our current theories predict. For now, no one knows the answer. And that's exactly what makes discoveries like this so exciting. Sometimes the greatest value of science isn't solving a mystery. Sometimes it's discovering an entirely new one. Webb has reminded us that despite all our technological progress, we still know surprisingly little about the earliest chapters in the history of the universe. But perhaps the discoveries that capture our imagination the most aren't about galaxies or black holes. They're about worlds that may be covered almost entirely by vast oceans. Worlds that may one day help answer one of humanity's oldest questions. Are we alone in the universe? Of all the discoveries Webb has made so far, this may be the one that captures the imagination more than any other. For decades, scientists have searched for planets that might resemble Earth, worlds with atmospheres, liquid water, and conditions that could support life. But more and more often, a different question is being asked. What if life could exist on planets that are nothing like our own? Webb is currently studying many exoplanets unlike anything found in our solar system. Among them are worlds that may belong to a class known as ocean worlds. These are planets where enormous amounts of water may cover much of their surface. Some models even suggest oceans far deeper than all of Earth's oceans combined. One of the most fascinating examples is a planet known as K218b. Located more than 100 light-years from Earth, it orbits a small red dwarf star. Its atmosphere has become one of Webb's most important scientific targets. By analyzing the starlight passing through that atmosphere, astronomers have detected molecules including methane and carbon dioxide. That's an important discovery, not because it proves life exists there. We have no evidence of that, but because it shows just how much we can learn about a world located an almost unimaginable distance away. Some scientists believe a vast ocean could lie beneath the planet's atmosphere. Others urge caution and emphasize that many more observations will be needed before drawing any conclusions. And that's exactly how science works. Every new discovery leads to new questions. Webb hasn't found life beyond Earth. It hasn't discovered a second Earth either. But it has revealed something just as extraordinary. It has shown us that the universe is filled with worlds far more diverse than we ever imagined. Perhaps the answer to one of humanity's oldest questions is waiting on one of those distant planets. Or perhaps reality is even stranger than anything we've imagined so far. And that brings us to the most remarkable part of this story. Everything we've talked about today comes from just the first few years of Webb's mission. The most extraordinary part? This is only the beginning. In just a few years, Webb has discovered galaxies that shouldn't have existed so early in the history of the universe. It has looked inside stellar nurseries where new stars are being born. It has analyzed the atmospheres of distant worlds. It has helped scientists investigate supermassive black holes from the dawn of cosmic history. And it has identified planets that may hide vast global oceans. Yet everything we've seen so far suggests that Webb's greatest discoveries may still lie ahead. Perhaps one day it will find a world that truly resembles Earth. Perhaps it will provide the first compelling evidence that life exists beyond our planet. Or perhaps it will reveal something we can't even imagine today. History has taught us that every time humanity builds a more powerful tool to explore the cosmos, the universe surprises us with something completely unexpected. And there's every reason to believe this time will be no different. Now, I'd love to hear your thoughts. Which of James Webb's discoveries fascinated you the most? Let me know in the comments below. And if you enjoyed this journey through the universe, don't forget to subscribe so you won't miss future episodes. Thank you so much for watching. I'll see you in the next episode.